بسم الله الرحمن الرحيم.
Starting with the name of Allah, who is the most beneficent and merciful. Assalamu alaikum class. I hope you all will be fine. So today we are starting the new chapter, that is the chapter number 10, chemical energetics. As we know that every substance possesses some kind of the energy, and we know that energy is the form of the heat. So it means that every substance possesses heat. So when these substances react in the chemical reaction, so definitely there must be the change in heat will occur. So that change in heat in chemical reaction we study in the thermochemistry. As its name is indicating, therms means heat, and we are well known with the term chemistry. So it means thermochemistry is that branch of the chemistry in which we study about the change in heat which occur in the chemical reactions. Like in chemical reaction, there may be the release of heat and their energy may be absorbed. So there are two forms of the thermochemistry. First is the exothermic. First is the exotherm and another is the endotherm. Endotherm. So there are two forms of thermochemistry, exotherm and endotherm. So firstly we are going to discuss about the exothermic reaction. Okay, so let's see exothermic reaction. As its name is indicating, exo, we know that exo means outside, and however therms means heat. So it means exothermic reaction is a reaction in which the heat will evolve or release. As you may take the example of the burning of the coal. Take a piece of the wood and burn it. So wood will start to burn. So you will observe that the heat will be released. So what is this? It is an example of the exothermic reaction. Another example you may take, when you boil the water, so you can observe that the heat will evaporate. It is also the example of the exothermic reaction. Except this respiration process in which we inhale and exhale. Right? So respiration process is also the example of exothermic reaction. How? When we take some food like rice, potatoes, we know that they are rich with the carbohydrates, and glucose is the form of the carbohydrate. When we take oxygen, and we know that oxygen helps in burning, so when oxygen reacts with that one glucose molecule, so it oxidizes the glucose molecule. As a result, carbon dioxide and water is produced with the maximum amount of the energy. That one energy our body utilizes to perform the many functions. Right? So respiration is also the exothermic reaction. In this way, there are many examples of exothermic reaction. So as we are discussing about the exothermic reaction, and here we can explain the example that when you boil the water, take a container and provided it heat. So when you will provide the heat, so what you will observe, you are giving the heat energy. You are giving the heat energy to that. And in this system, the heat energy is flowing from system to surrounding, as the heat is moving from system to surrounding. So in exothermic reaction, the heat flows from system to surrounding. Heat flows from system to surrounding. And when the heat flows from system to surrounding, then tell me that can you touch that one container? When you are providing the temperature to any container, then can you hold that one container? No. So it means that when the heat flows from system to the container, then the container becomes hot. Then the containers become hot. Right. So as another example I have given you about the burning of the coal. So if I write this reaction in terms of the chemical equation, so how I will write? Okay, let's see. Burning of coal. We know that coal is the form of the carbon, and burning means oxygen, because oxygen helps in burning. So when carbon dioxide react with the oxygen, so what the product will be formed? Carbon dioxide will be formed with the emission of energy, and that would be delta H is equal to minus 393.7 kJ per mole. So when 1 mole of carbon dioxide react with 1 mole of the oxygen, so 1 mole of the carbon dioxide will release, as well as the energy, that is a 393.7 kilojoule per mole will release. The question may arise that is it the constant value? Is it necessary that this one amount will be released? So yeah, definitely. When you will use the 1 mole of carbon and oxygen, so definitely this amount of the energy will release. When you are increasing the mole of the reactant, if you are increasing the 2 mole of the carbon with 2 mole of the oxygen, so definitely the release of the energy will, the amount of the energy will also would be double. Okay, so here kJ per mole, it means kilojoule per mole. What is it? It is the unit of energy. And what is this? Delta H. So as we know that every substance possesses some energy, so that one energy is known as heat of that substance, or you may also say heat of that content. Again I am repeating, as every substance possesses some energy, so it is known as the heat of that content, and it is represented by the H. The energy absorbed or released by any substance, it is known as its enthalpy. It is known as its enthalpy. Right? The energy absorbed or released by substance, it is known as its enthalpy. Right? So as every substance possesses some heat, so as every substance possesses some heat, so it means it's called the heat of that one substance, and it is represented by the H. When that one substance react in the chemical reaction, so there must be the change in heat will occur, and that change in heat we represented by a Greek symbol, that is the delta. It is called delta. Delta mean change. Change in what? If H is with it, so it is known as the change in heat. So that's why we call it delta H. It means change in heat. Right? So here, that's why we have placed a sign delta H. In the reactant, the heat was different, but after the product, the change in the heat definitely has been occurred. So that's why we will place the sign here delta H. And why we have placed the sign minus? When the heat of the reactant, as we know that the substance before the arrow are known as the reactant, and the substance after the arrow are known as the product. right? So definitely the heat before the reaction and after the reaction will alter, will be changed. So if the heat of the reactant will be greater than the product, when heat of the reactant is greater than the product, then we place the minus sign. It means when the heat of the reactant will be greater than the heat of the product, then delta H would be in minus. Right? Another example we may take methane. Its formula is CH4, and we know that methane is a gas which you commonly use, which is commonly used as a domestic fuel. It is also used in your as a fuel in your vehicles, which you also call CNG. That is a compressed natural gas. Right? So when methane burns with oxygen, when methane reacts with oxygen, so what it produces? When methane burns, it means react with oxygen. So what it produces? It produces carbon dioxide, water, and 1 mole of the methane will be reacted by 2 mole of the oxygen, 1 mole of the carbon dioxide, and 2 mole of the water will be formed. Change in heat, that would be minus 890 kilojoule per mole. Right? So when methane react with oxygen, when 1 mole of methane react with 2 mole of the oxygen, so 1 mole of the carbon dioxide and 2 mole of the water, with the emission of the heat, that would be minus 890 kilojoule per mole will be released. It is also the example of the exothermic reaction. Another example you may take, like when hydrogen react with half mole of oxygen, what the product will be formed? Water will be formed plus delta H is equal to minus 286 kilojoule per mole energy will be released. Right? So these all are the examples of the exothermic reaction. Except this, there are many examples of the exothermic reaction, as we have discussed about the respiration. Okay, so glucose molecule C6H12O6 when react with oxygen, means oxygen O2, then what the product will be formed? Carbon dioxide, water, and in the bio we have discussed ATP, and we know that ATP is the energy form, so it will produce, it is also the exothermic reaction. Except this, the exothermic reaction is also used by our modern army, as we know that the army have to survive typically, so they also have to move in certain places where the gas or the fire is not available, so they use the exothermic reaction to warm up their food. How they warm up their food? As they have the food pouch, so they place a flameless radiator heater with their food pouch. As it is their food pouch, they place a flameless radiator heater with their food pouch. After that, they place it into the bag and they added the water in the bag. So when here, let me draw the diagram. As it is a flameless radiator heater, it is a food pouch. Food pouch will be attached by the flameless radiator heater, right? Then it would be placed into a bag. In the bag they will introduce the water. This one flameless radiator heater is made up of magnesium, iron, and NaCl. When as we have placed the water into the bag, so when water will be reacted by the magnesium, so what the product will be formed? Okay, see this example. when magnesium, which is present in the flameless radiator heater, when it would be reacted by the water, so magnesium hydroxide MgOH2 would be produced. Right? So magnesium hydroxide will be highly accelerated in the presence of the iron and the NaCl, that within 15 minutes the temperature may reaches up to 60 degrees centigrade. Right? So exothermic reaction can also be used to warm up the food. So now let's come to know about the endothermic reaction. Again, I am repeating, what do you mean by the exothermic reaction? Exothermic reaction is a reaction in which the heat is released. And here we have discussed the many examples related to the exothermic reactions. Okay, now see the endothermic. Endothermic reaction. Definitely it would be the opposite of it, as endo. Endo means inside or absorb, and therms mean heat. So its mean endothermic reaction is the reaction in which the heat would be absorbed or intake. Right? So here we can take the example as take a glass of the water and place it into the diffuser, as the system, as the surrounding one environment, as it is the it is a freezer. So definitely the cool environment is present here. Right? So, and you are placing a glass of the water into it. So, the heat will be flow from system to the surrounding. Isn't it or not? So, when you place a glass in the deep freezer, so after the short time, after the 2 hours, what will you observe? The glass will be cold. Right? So, in endothermic reaction, the heat flows from surrounding to system. In endothermic reaction, the heat flows from surrounding to system. And however, in the exothermic reaction, the heat was flowing from system to surrounding. Right? As a result, the container was becoming hot. But in the endothermic reaction, when the heat will flow from surrounding to system, so the system will become cold. So the container will become cold. All the decomposition reactions are the example of the endothermic reactions. Right? So here we can see the example of the formation of water. Right? So when here you are treating the water, and when you will provide it heat, so definitely firstly the water will absorb that one heat. When it is absorbing the heat, so it is the endothermic reaction. Then water will split into its compound, that is the hydrogen and oxygen, with the emission of the some energy, and that would be plus 286 kilojoule per mole. Clear? So here we know that substance before the arrow is the reactant, and the substance after the arrow is the product. In endothermic reaction, the product are greater than the reactant. And however, in the exothermic reaction, the energy of the reactant was greater than the energy of the product. But in the endothermic reaction, the energy of the product is greater than the energy of the reactant. When this situation would be, then its value delta H would be in plus. Right? Delta H means change in heat. Another example you may take, that is the CaCO3, calcium carbonate. When you will provide it heat, as in the starting I have told you that all the decomposition reaction are the examples of the endothermic reaction, because we know that in decomposition reaction the capacity the substances absorb the heat, and absorption of the heat is related with the terms endothermic reaction. So CaCO3, that is the calcium carbonate, when heat would be absorbed by calcium carbonate, so it will decompose into its compound CaO, calcium oxide, and carbon dioxide. As a result, heat will also be evolved. Right? So here exothermic and endothermic topics we have covered. Next is the measurement of heat or measurement of the reaction. Okay, if I am placing a container and I am after the reaction, I am placing a container and I am asking to you that which one reaction has been occurred, then how you will identify that it is either the exothermic or endothermic reaction? You can identify the reaction after touching the vessels. How? If the container will become hot, so it means it is an exothermic reaction. If the container will become cold, so it means that it is the endothermic reaction. Except this, the calorimeter is also used to measure the heat. Calorimeter is also used to measure the heat. As we know that it is delta H, it means change in heat. So as it is typical to measure the heat, so we can also measure the heat by subtracting the heat of the reactant, from the heat of the product. Delta H, change in heat, H2, heat content of product, and H1 is the heat content of reactant. So when you have to calculate the delta H, so how you will calculate? You will subtract the heat of the reactant by the heat of the product. So by this you can calculate the heat. Except this, the last thing, that is the heat of the neutralization. Heat of the neutralization. As we are well known with the terms neutralization, we have discussed in detail in chapter number 9. What do you mean by the neutralization? So neutralization is a process in which acid, take the example of HCl, react with base NaOH. When acid react with base, so salt and water are formed and it would be NaCl H2O. It is a neutralization reaction in which acid react with base, as a result salt and water is formed. Right? So it is the neutralization reaction. As when 1 mole of in the formation of 1 mole of water, minimum amount of energy will be released. As this example I have given you in the exothermic reaction. In exothermic reaction, water H2O, when you will provide it heat, so what would happen? It will decompose into its compound H2 and oxygen. So when those one heat which would be released in the process of the neutralization, it would be known as the heat of neutralization. That one heat which would be released in neutralization, it is called heat of neutralization. Right? So here we have completed our chapter number 10. It is the shortest chapter in your syllabus because in detail you will discuss this chapter in first year class. So today what we have discussed about the exothermochemistry. It is that branch of the chemistry in which you study about the change in heat in the chemical reaction. After this, we have discussed it has two types, exothermic and endothermic. What do you mean by the exothermic reaction? Those reactions in which the heat is released or evolved, it is known as the exothermic reaction. In exothermic reaction, the heat flows from system to surrounding. As a result, the container becomes hot. In exothermic reaction, the heat of the reactant is greater than the heat of the product. That's why it is delta H is represented by the negative sign. What do you mean by the delta H? Delta is the Greek letter. Delta is the Greek letter which is used, which show the change in. Here delta H, so it means change in heat. After this we have discussed about the endothermic reaction. What do you mean by the endothermic reaction? The reaction in which the heat is absorbed or intake. Right? There are many examples of the endothermic reaction which we have discussed there. In endothermic reaction, the heat flows from surrounding to system. And there we have given the example of you are placing a glass of the water in the fridge. As a result, the container will become cold. In endothermic reaction, the heat of the product is greater than the heat of the reactant. The question in your board exams, the question may come like differentiate between the exothermic and endothermic reaction. Right? So, you can differentiate between the exo and endothermic reaction. We also have discussed about the measurement of the heat. Heat may be measured by the calorimeter, and here we have discussed about its formula. In the last we have discussed about the heat of the neutralization, the amount of the heat which is released in the process of the neutralization. It is called the heat of the neutralization. Right? So here we have completed our chapter number 10. If you have any query, then you can contact us on our WhatsApp number, and your work will be mentioned on our web portal. See you in next class. Till then, Allah Hafiz and take care yourself.